Where does 802.11 fit in the protocol suites that we have? Remember, we have two types of model, right, for computer networks. One was OSI, 7-layer reference model, if you remember that one. Application, session, presentation, transport, network, data link, and physical layer. And the other one is TCP/IP. In TCP/IP, forget the presentation and application layer, make it one big layer, session, presentation, application. And then we have transport network, data link, and the physical layer. Transport layer, we are using TCP. Network layer, we are using IP. Data link layer, we have two protocols in data link layer. One is called LLC, Logical Link Control, and the other one is called MAC. MAC defines your network card, which network card you're going to use actually. Ethernet, token ring, token bus, 802.2, 3, 4, 5, those guys are going to be there. Okay? In LLC, it's a logical link control, okay, which is going to handle link basically. It's going to manage the communication link. At the physical layer, you're going to use whatever the cables that we are using. Yeah, the stuff that I was just talking is this. As you see, application layer, all the applications. Presentation layer, NFS, okay, FTP, Telnet, these are presentation and session layers, okay. Forget this NetBU, the IPX, because it is no longer NCP, IPX, SPX is no longer available anymore, okay. These were for novel networks, if you remember. Okay. So we are going into this direction, TCP, UDP, Internet Protocol. But what is important for us as far as 802.11 is concerned, data link and physical link. Okay. If you look at the data link layer for the wired networks, 802.3, Ethernet. 802.5, token ring, these are all MAC protocols. And FTDI, token ring, right? FTDI is right there. At the physical layer, Ethernet is using 10-base-T, 10-base-2, 10-base-5 cables. These are the types of cables that we are using. Or 100-base-T or 100-base-X, okay? And for token ring, fiber optic twisted pair, and for FTDI token ring, fiber optic 100 megabits per second cables. But look at the wireless right now. When we discovered the wireless, we had to add a new MAC layer, okay? Because we cannot use this MAC layer for wireless environments. So you see, MAC for 802.11 VLAN, that is the MAC layer. Okay, that's the MAC layer. That is 802.11 protocol. Okay, and at the physical layer, we may use 900 megahertz DSS. What is this DSSS stands for? What DSSS stands for? Have you heard spread spectrum communication systems? This is a secure communication system used in military. This is called direct sequence spread spectrum. Again, this is the DSSS, direct spread spectrum, and FHSS, frequency hopping spread spectrum. Okay, both of them are spread spectrum technology. Okay, both of them are spread spectrum. It came from military anyway. Okay. Maybe you can see some examples in commercial world, especially for frequency hopping. You have wireless phones in your house. Okay. If you don't want to someone hear your telephone conversation because it's wireless, okay, sometimes you hear your neighbors, right? You hear some noise. Sometimes it is intelligent, sometimes unintelligent noise, by the way. But here you do hear something. If you want to avoid those kind of things, you're going to go and buy FHSS-based telephone. That means that the communication between cell phone and the base station is going to be based on this frequency hopping system. With this frequency hopping spread spectrum, carrier frequency of the signal is changed for the commercial world 16 times per second. 16 times per second, based on some algorithm. For example, I'm modulating a signal in the F1 frequency at T1 time, but in T2 time, I'm using F2 frequency. It's total different frequency. I'm jumping or hopping from one frequency to other frequency. Okay, one frequency to other frequency. That's called frequency hopping spread spectrum. And they are changing the frequency 16 times in commercial telephones, but in military, Air Force is using this. In other words, planes are talking with this technology. They change 2,048 different frequencies per second. 2,048 different frequencies per second. If you want to listen to them, okay, you have to manage to find this hopping sequence for the frequencies. Okay? If you can find that one, you crack the communication, but it is going to be very difficult. I mean, because those frequencies are selected quite randomly. Okay? 2,048 different frequencies per second. Per second. So that gives. Now we are using that kind of technology on cell phones, but of course they are not using 2,048 different frequencies. 16 is enough for us, if not 64. Okay. So wired and wireless protocol in International Standard Organization ISO Open System Interconnection Reference Model is going to be this, guys. As you see, major difference is not the upper layer protocols. We are still using TCP/IP for transport and network layer. The biggest difference is in the MAC layer and in the physical layer. In physical layer, we don't have cables anymore. It is wireless environment. And in the MAC layer, we have IEEE 802.11 MAC. Okay? And we will see the protocol structure anyway. Okay? But we're going to see it from the security perspective. Okay? So that's why 802.11 fits in the ISO reference model at the data link layer and the physical layer. It doesn't care the other layers at all. Okay? In the TCP/IP model, in application layer, email, web, wireless web, MPEG-3, streaming audios are all these application layer things. At the transport layer, we are using socket programming. Okay? UDP, TCP. This RTP is important right now. What is this RTP? Real-time transfer protocol for multimedia applications. Okay, and then at the network layer, we have routing algorithms, congestion control, quality of services, and we are using IP version 6 right now, right? And MAC sub-layer, as you see, Ethernet, 802.11, broadband wireless. We're going to discuss this one too. So which wireless technology is broadband? So far, we said IEEE 802.11 is WLAN, wireless LAN. It is not broadband. Okay, it is not broadband. So do we have any broadband wireless that you guys are aware of? Broadband wireless. Well, we have one, actually more than one, but the one is particularly important because everyone knows the name of that one. It's called WiMAX. WiMAX is wireless broadband. Okay? And the other thing is that these guys are developing these IEEE guys. I think it's called IEEE 802.20. So that's going to be the broadband wireless protocol. Data link, in data link protocol principles, protocol verification, HDLC, point-to-point. HDLC and point-to-point is the major thing for us. Okay, because data link layer is based on that one anyway. And the physical layer, fiber, copper, wireless, satellites, internet over cable, all those things are going to come from the physical layer. Okay? But for the wireless environment, anyway, we have only wireless environment. Okay. IEEE 802.11 intended for the MAC and physical layers. We are agree on that one right now. Okay. So let's have a look what type of stuff they have. Okay. What type of stuff they have. I said that at the MAC layer, data link layer, we have two layers, LLC and MAC. One is logical link control, as you see. LLC is still same LLC. Okay. But what is important for us is this MAC layer. Okay. In MAC layer, let's start from the physical layer. And they are using 2.4 gigahertz frequency hopping spread spectrum, or 2.4 gigahertz direct sequence spread spectrum, or they are using infrared. Okay, they are using infrared. But this is for IEEE 802.11a and IEEE 802.11b protocols. B protocols. Okay. And 5 gigahertz orthogonal frequency division multiplexing, OFDM. Okay, OFDM is used. Okay, and data rates is going to go to 54 megabit per second speeds. Okay. And 2.4 gigahertz direct sequence spread spectrum and 11 megabit per second speeds. So A is using this 5 gigahertz. Okay, 5 gigahertz orthogonal frequency division OFDM. What is the latest one? IEEE 802.11 N. Exactly. N is the latest one. Okay. N is the latest one. And N is also using 5 gigahertz bandwidth with OFDM. With OFDM. But the speed is going to be 150 megabit per second max. 150 megabit per second max. Okay. So they turned a little bit to A with the OFDM at the physical layer, but the speed is much, much higher. Okay, 150 megabit per second speeds. All right. And then when we come to this distributed coordinated function, DCF and PCF, okay, let's have a look from here. In the medium access control, we have physical layer, we have the frequency division band, okay, right here, and the other details of the radio transmission, okay. But for the medium access control, when we come to MAC, it has two sublayers, DCF and PCF. DCF uses Ethernet-style connection algorithm that provides access to all traffic. Okay, you guys tell me, how we are sharing the cable on Ethernet? What is the access protocol? You are close. It starts with letter C, CSMA, CD, right? CSMA, CD, collision detection. Carrier sense, multiple access with collision detection. Okay? We have the same kind of stuff over here, DCF. Okay? So they are using the same, let me put it this way. Okay, although we have a wireless connection, but the spectrum is going to be shared, or wireless channel is going to be shared. That sharing is going to come from DCF. And this point coordinator function, PCF, is going to have a centralized MAC algorithm providing contention-free service by polling stations in turn. So in other words, it's going to avoid the congestion for that particular wireless channel. Okay? When the channel is available, they are going to pull the guy. They will say that, okay, go and use it based on this DCF. Okay, based on this DCF. But anyway, this is for the wireless networks. Our subject is not wireless networks. Our subject is security in wireless networks. Okay? So this is just a summary. Okay, this is just a summary. So logical link layer is going to provide interface to higher layers. Okay, higher layers is going to be, in other words, IP layer is going to be connected. Whatever the IP you guys are using it in wired networks, we have the same functionality. If you want to use IPsec, you can use IPsec for security. Okay? If you want to use IP version 4, yes, you can. IP version 6, yes, no problem at all. All the above protocols are transparent. Whatever you are using in wired networks, you will be able to use it in wireless networks. Okay, as far as above layer are concerned. But for the data link layer and the physical layer, things are different. Okay, things are different.